Hello, welcome to Chapter 7, Completing the Triangle Toolkit, homework questions 77 through 82. Question 77. To paint a house, Travis leans a ladder against the wall. If the ladder is 12 feet long and it makes contact with the house 14 feet above the ground, what angle does the ladder make with the ground? Draw a diagram of this situation and show all the work. So we're taking a look and we have a house. Here we go, my beautiful house. We have a ladder leaning up against the house. Alright, and with that, we know that the ladder is 16 feet long, so we have 16 feet here, and it makes contact with the house 14 feet above the ground, so 14 feet above the ground from here to here would really be that side, so that's 14 feet, and it wants to know what angle does the ladder make with the ground. So here's the ladder, here's the ground, we're looking for this angle. What trig ratio uses opposite and hypotenuse? And so opposite and hypotenuse would be sines. We'd say sine of theta is equal to 14 over 16. And we would need to work backwards. So we're going to do the inverse of sine for that ratio. And that will give us the angle value. Make sure your calculator once again is in degrees. Do the inverse of sine of 14 divided by 16. Or you could reduce the fraction. And you should get an angle approximately at 61 degrees. And so that's the angle that you would need for the ladder and the ground. Question 78, wacky diagrams. After drawing some diagrams on his paper, Jason thinks there is something wrong. Examine each diagram below and decide whether or not the triangle could exist. If it cannot exist, explain why not. So in part A, we're given all three side lengths. And for this to work out, we need to make sure that Pythagorean theorem works, which means 6 squared plus 12 squared is going to be equal to 11 squared. Now, we don't even need to go any farther because if you notice that your hypotenuse, what's supposed to be your hypotenuse, should be the longest side. And since 12 is a leg, it represents the longest side as a leg. And therefore, that's impossible because the 90-degree right angle, the side length across from that has to be the longest side. So on part A, it is impossible. So once again, it's impossible because a leg is longer than the hypotenuse. On part B, we have three angles of a triangle, 26, 42, and 119 in terms of degrees. And if this is true, one of the things that we need to check is that the sum of all three of these angles should add up to 180 degrees. So if we add up those numbers, 26 plus 42 plus 119, we get 187. So that is not equal to 180 degrees, so therefore this is impossible because the sum of the angles is more than 180. Or I should say is not equal to 180. And so once again, make sure you clarify why it is impossible. Question 79, William thinks that the hypotenuse must be the longest side of a right triangle, but Chad does not agree. Who is correct? Support your answers with an explanation and a counterexample if possible. Well, we just kind of had this question a little bit ago on the last one, that the hypotenuse is the longest side across from the right angle. And to kind of potentially show that, we have, this is 90 degrees, and so the other two angles, no matter what they are, this angle has to be less than 90 degrees, and this one has to be less than 90 degrees because they have to add up to 90. And so therefore the hypotenuse will always be across from the larger angle, and so therefore the hypotenuse, no matter what, of what right triangle, is always going to be the longest side. So William is correct. Question 80, plot triangle ABC on your graph paper using those points, and then we're going to transform by multiplying the y-coordinates of the vertice by -1. So let's go ahead and plot the points first. Alright, so I went ahead and graphed it. Now we're going to multiply the y-coordinates of the vertice by -1. So how are these going to change? Well, everything just changes to the opposite. So instead of 3, 3, now it's 3, -3. 1, 1 becomes 1, -1. And 6, 1 becomes 6, -1. So let's go ahead and transform that. And then it says, then use the function xy to subtract 6 from the x and subtract 6 from the y to translate the resulting triangle. And then we'll name the coordinates of the vertice of the result. All right, so let me plot the new points, 3, negative 3, just to kind of show you, and then we'll move them from there. So 3, negative 3, 1, negative 1, and 6, negative 1. And you can see that just reflected over the x-axis. But now we're going to move them to the left 6 units and then down 3 units. So I'm just going to take each of these points and go left 6. So I'm just going to count 1, 2, 3, 4, 5, 6, and then down 3. So this would be my new point B, B prime. And then on C, we're going to go 6 over and then down 3. So this would be my new C prime. And then A, 6 over and down 3. And that should represent my new A prime. So let me write these down on here. A prime now appears to be at negative 3, negative 6. B prime looks like negative 5, negative 4. And then C prime looks like 0, negative 4. And then we'll graph that. Alright, so we've named the coordinates of the new vertices of the result, so we look good there. And then on B, we're now going to rotate triangle ABC. So we're going to go back to the original. We're going to rotate it 90 degrees counterclockwise about the origin, and then reflect the result across the y-axis. So we got 2 things to do here. I'm going to get rid of these other points that I don't need. And so we're first going to rotate it 90 degrees. So you think about using your tracing paper. Rotate it 90 degrees to the left, counterclockwise, and then reflect that across the y-axis, which is right here. So we're going to rotate it 90 and then reflect it across the y-axis. So I've shown the rotated points. Now I'm going to reflect them across the y-axis. So this will represent C prime, or we can use double prime. And then A actually gets reflected right back on to the original A, and B, it does exactly the same thing. So A prime, or A double prime and B double prime are back where A and B were. C is the only one that is not there. So here's would be our new triangle. Let's go ahead and label. A is still going to be at 3, 3. Or A double prime would be at 3, 3. B double prime is still going to be at 1, 1. And then C double prime is now going to be at 1, 6. So that's when we rotate it counterclockwise about the origin, use that patty paper, and then take the result and reflect it across the y-axis. Question 81. Solve the equations below. If possible, if there is no solution, explain why. So let's go ahead and just start with A. I'm going to go ahead and multiply both sides of the equation by 2x, and I'll show that below. So I'm going to do 2x over 1 times 8 minus x over x is equal to 3 over 2 times 2x over 1. And what's going to happen is you have x divided by x, which creates that giant 1, and then you're left with 2 times 8 minus x is equal to 2 divided by 2 is 1, and then 3 times x. So we'll go ahead and distribute the 2. We need to get the x's on the same side, so we'll add 2x to both sides. Creates a 0, and then 16 is equal to 5x. And then when you divide by 5, you get x equals 16 over 5. Alright, on to B. B, we can go ahead and distribute the negative 2, so that would be negative 10x. Negative times a negative would be a positive, so that's plus 2. Minus 3 is equal to negative 10x. Combine like terms. And then when I add 10x to get the variable on the same side, we're left with negative 1 equals 0, which is not a true statement. So do we have any solutions? And the answer to that is no. There are no values for x that are going to make this equation true, because negative 1 is never equal to 0. Question C, x squared plus 8x minus 33 equals 0. So it looks like we maybe want to try to factor this one. And looks like we could do it. We got 33 and 11. Let's see how I could work this out. Plus 11 minus 30 would give us negative 33, but add up to 8x, so that looks good. You can also use your generic rectangle if that method doesn't work to work your way through that. Now we can set our factors. I'm going to work up here. Set our factor equal to 0 by using the zero product property. And we will get two solutions, x equals 3 and x equals negative 11. So two solutions to the quadratic equation. And then the next one is linear. We'll add 12 to both sides. That'll leave us with 2/3 x equals 192. And if we want, we can do this in 2 steps, or we can do it in 1. Multiply by 3. I'm going to multiply by the reciprocal 3/2. I'm going to do it in 1 step instead of 2. 3/2 times 2/3 is 1, so that's x is equal to, and then we can take 192 and times it by 1.5. We can multiply by 3 and then divide by 2, however you want to do that. But we should get 288 for x. Question 82, multiple choice. Based on the relationships provided in the diagram, which of the equations below is correct? Justify your solution. So since we're looking at an isosceles triangle, the angles opposite those side lengths should also be congruent. So 4x plus 2 and 9x minus 3 should be equal to each other. So which one of those matches up? 4x plus 2 equals 9x minus 3. That one is correct. And the other ones we had equal 90. They're not. We don't know they're complementary. We don't know that they're supplementary. And we can't multiply them and get 90. So it looks like B is the only correct choice on this one.